So if anyone is just joining us right now, if any new users are just joining us, we're going to get started. This is the Cheat Layer Product Lab, our private community of founders who are building transparently to help each other. We basically learned that through the metrics, we actually do make the most profit by teaching users to build valuable products and use our white labels. So we scaled up from the one-on-one meetings of helping users to this weekly meetup to try and scale up and help more people in sort of the same amount of time. And the idea is in these meetups, we discuss the current research, any current projects, and try to inspire products. And as we gather more success stories in our community, the hope is that our community will fill with founders helping each other, sort of paying it forward. For example, we have a cool success story coming up. Schedule is launching on AppSumo, I think maybe in the next 2 weeks. And we have the founder here, Ritesh. I think they also do plan to maybe offer Cheat Layer users a free stacked code for being an early supporter. That's another perk of being part of this community. We're offering our partners all of the historically redeemed Cheat Layer codes so that you can offer Cheat Layer users perks. So over time, one Cheat Layer code will get you perks across many different products that spin out of Cheat Layer. But also founders get the chance to jumpstart their products and get it like users immediately and get early supporters from our community, which is mostly power users and automation experts. So, hey, Ritesh, do you have any plans, or do you know when you're launching?
Yeah, so next week will be our beta launch. We had planned to launch it this week, but we had some tech issues. So next week we'll be doing the beta launch, and 2 weeks from then we'll launch it on the apps only.
Okay, cool. That's exciting. That's great. Yeah. And we also have another user here from the bootcamp who built a working product, a Facebook group scraper, Andrew. I think I was excited about that project too. You were like number one. Actually, we have number one and number two from our bootcamp. Ritesh won the grand prize, and number two was Andrew. And so kind of cool to have you guys here. We're also very excited to have Nisar here because he's like an expert in machine learning. He has a PhD with patents, and he's also built like actual products in machine learning. And that's kind of like exactly like the intention behind this meetup is to kind of inspire products. And I really like especially focusing on machine learning as a market because I feel like we can solve many difficult problems very easily without spending millions of dollars now, and just like to prompt design or properly using existing models and things like that. And I feel like Nisar, you might have some experience. You probably you're much better at explaining your own experience. So would you mind maybe briefly explaining your experience or things that you're working on and things?
My name is Nisar Hundewale. Just to give you a brief about myself, in computer science from Georgia State in 2007, worked as a postdoc with National Institute of Health, and that was a time pretty much Google and IBM were getting into the big data science areas, and was a time to get into this area. Not that I had started my career in data science at that time, but actually I've been working on AI in 90s, and since then I've been working on this, but hasn't been called as a data science, but it was practice since long before these words were coined. So after that, I worked with in the university for a couple of years, published several papers, and also have a patent in computer vision and AI, followed by working with very large companies such as Walmart and Johnson Johnson, Eli Lilly, and Nielsen, a lot more into the healthcare as well as the retail industry. I've worked with a very large data set at Walmart as well. Was fascinating experience. And so working in industry, and realize across the board for multiple of the clients in different verticals, issues which are some of the things are common problems. However, the data is different. The patterns in the data is different. You pretty much have built almost custom models for each business or client. And throughout this experience, I realized there are certain issues the industry is facing. 2015, I started launching my own product, working on my own product, and started my own company, computing. And so, pretty much, we are doing what I have been doing is that there is a huge challenge with the unstructured data. Now, how's that small companies or companies who are starting, not necessarily small, but could be even larger companies who are early on in their start in their journey, and how expensive it is for any company to start this data science project, put a team and resources, and even then you need also a lot of data, real data, to be able to build these realistic models, internal data, external data sources. So this is a challenge, and that's why I have seen that a lot of times, if you don't have correct combination of this success factors, then you may see that the data science projects fail for various reasons. And there are four that I've seen that the subject matter expertise, including the expertise in the AI data science, as well as the subject matter expert in the industry itself, in the wording and the technology and the data science approach, and then of course the technology that goes with it. So all of those are important factors, and without having this right combination, then the the project fails, and it becomes often expensive and not meeting the needs. Eventually, people give up on data science itself completely, or think that this is not something works for them. The very real experiences people have, companies have seen, businesses have seen, and how do we actually help them to monetize on the available data, available models, as Rohan mentioned earlier as well, and in previous podcasts as well. So how do we actually monetize what is out there, and to quickly utilize this models and build the models and put in production, and really benefit from all this cool work that has been going on in the industry. And it's not the research work, but it is something that you want to really leverage on what someone has actually developed, and solve your problems. This is not just a technology, but it's a science behind it. So obviously it matures as it being utilized and applied to different problems. So what we have done is at UNIC was to be able to help the companies to leave all this hard working, all this heavy lifting from extracting the information from various data sources. There are companies who are specialized in just bringing the data from various sources and providing you the data through APIs. Great, that's fine. But then what next? You have tons of data all of a sudden, and then that also creates a challenge. So we are into being able to identify, process this unstructured data, meaning that I think text, image, video, audio. These are very challenging areas. These challenging problems that comes with this unstructured data, and extracting the information, right, features from this data becomes very challenging, and has own techniques in each of this area. And we have worked on to build these pipelines, apply learning models, and apply and develop some of our own models as well, to be able to create this feature store and model store ready for someone who is is a small data science team who can create this work and put it into the action and try to integrate into their product, and being able to deliver solutions without having to reinvent the wheel. And that's the concept that we are trying to bring it to the industry, where as software engineering has evolved into in the steps of reusing the artifacts. Now we are we are also going through that phase of reutilizing the models that have been developed and trained uh, by some of the providers, and quickly come up with a reusable model architecture and monetize it. So that way, you can quickly see and really you're pretty much leveraging on years of man hours or machine hours that have been put into in developing and fine tuning these models are available at your fingertip. You can utilize them and put into production. And that's our providing our solutions. And I see that CheatLayer is also providing the the approach, which is a great approach to be able to utilize the automation tool and being able to monetize it, solve your problems without having to do a lot of heavy lifting. And I think this is a concept that is going to go on instead of having to start from scratch unless it is necessary.
Yes, that does seem like a very valuable problem to solve, to like make the barrier of entry for all these tools much lower, make it easier for everyone, because I feel like that would immediately open up the opportunities for many different businesses. What you were talking about reminded me of like how Palantir started with like a consulting division to do data analysis and things like that, but over time they built a framework to automate that process somehow. So by reusing maybe some of the techniques and what they learned and things like that. It's also very similar to Gatto. Have you heard of Gatto, the transformer model that does like
right.
images and everything? Yeah, I think that was kind of exciting.
Yeah, there are great tools out there. I'm sure we can also possibly post a list of available resources or compile and post it. That may be pretty handy. Such as, most of us have heard about Hugging Face and their Boom, and their and Model Zoo, and there are numerous of this initiatives which are being disrupt the industry, where you can see that there are tons of billions of models been produced and trained and available for you to utilize, and also it creates another challenge that you have too many of those models available, then it becomes a new avenue where choosing the right model. How do you choose the right model when you have too many of this? It's like you're walking into in a store, garment store. You're trying to look for a dress. You have all of a sudden too many providers, and which one is the right one for you? And obviously you need to know your size and color or whatever, and branding. Same thing is going here with now the model stores, or Model Zoo, rather, what some sites call. So case, it is a newer challenge of choosing now. If you're going through this process of, are you going to then try out models and see which is the best one for your set? Obviously, there's not one model that fits all data sets. So your data tells you what model really works for it. And obviously looking for the right model, and also it is not necessarily exact fit, then there could be some fine tuning as well, being able to retrain if needed. It is going to be an issue. So how do you actually work with those? So it is not something that you can just walk in. You need also some experienced data scientists to actually come and quickly help you to choose the right model and also fine tune if it's needed. I think that part. So it doesn't really replace data scientists, but it is making a lot easier for both the data scientists as well as all the stakeholders to be able to leverage on available models, and also engage with experienced data scientists who can help you to deploy a right model in right place
Yes.
and configure as well.
Yes, I like that you brought this up too, especially like Hugging Face and things. And I feel like you and I probably know what Hugging Face and what all these models are, but I think most of our audience and maybe even most people here don't know what it is or what the best models are. So it would be, I'd like to dig into this idea of what the models are available and maybe even go back and explain what Gatto is. So Gatto is a transformer just like GPT-3 and Codex, except instead of just text, it also takes tokens for text, images, and actions. And it's from DeepMind, so the technology there, this is their kind of solution to solve general AI. Sorry, were you going to say something? Or is that my echo? Sorry. Okay, it's okay. It's my echo. It's okay. So basically, I wanted to maybe dig into more about Hugging Face. What is Hugging? I mean, I know what Hugging Face is. I don't think most of our audience knows because most of our audience is actually non-technical users, but they are building products and we're making it easy for them to build products in no-code tools. So we're kind of trying to solve a similar problem to you. We're trying to meet users at their level of understanding using these large language models so that they don't have to be technical to build some of these cool things. And so I was wondering maybe if you could explain to our users what is Hugging Face and maybe what are like solid models that you know of today that are available to use commercially without having to pay for a license or whatever that you can deploy to solve problems that work in real time or something.
Great. So just to make it very, very simple to understand, machine learning models, as we all know, that are trained using some training data, and that data has to be a true representative of your the data that at your hand. Meaning, you take some of your historical data, feed it to the to machine learning models, which will train to understand what patterns exist and to predict, classify, or whatever regress future values, and this hoping that these patterns will remain the same. However, they're not. Then in that case, you will have to have retraining the model every time you get a new data, so often, so that you keep the models fresh. So it's basically all data driven to learn from the patterns or ever changing patterns, especially when we saw that last years most of these models were challenged because of the COVID scenario. Things are totally different than what were there before 2 years or 3 years ago, so till 2019, and that has posed a new challenge to improve the models and train the models. However, so this is the part of the data science life cycle. So if what we need is basically to be able to find data source to retrain the model, and that's just it's an ongoing process. And then oftentimes you need to actually bring in a lot of data from external sources, such as weather data and weather data and maybe demographic data and whatnot. So a lot of different things you need to be bringing to make the model rich. So this is a very expensive process, and oftentimes it is a challenge for people to be able to. And you need a larger team to be able to orchestrate it and being able to build models. So instead of all of that from scratch, then you can go to some of the pre-built models, such as Hugging Face, and other. They have used supercomputers to train the models on tons of data which is available out there. So decades of data, available public data, and build the models using the best of the parameters, and those are trained. For example, think about using all the news corpus, data to be able to train the models to understand uh, the language itself. And the language could be, different from healthcare to legal to different domains. So training those models for a particular domain becomes a challenge, and obviously challenge in the sense that it takes a lot of efforts. So this work has already been performed by this initiatives by like Hugging Face and many different other uh, you know offerings. And what you need to do is to be able to take that pre-trained model. That means the model learns actually the patterns from those particular domain. For example, healthcare is a particular domain by itself, and that language is different than newspaper language, or news language, or maybe something else, or legal language. So the models need to be trained in that particular domain, and the model can understand those terminologies and the intelligence behind this vertical. So that is has been performed, and those models are ready. Now you can go and look for the right kind of uh, that could be helpful to make sure that you are not going to go back to to going through this process of grabbing the tons of data, um, and data that has been being utilized and being able to uh, to train the models. So to save this efforts, you can go to the platforms like Hugging Face, and where tons of the models or different verticals have been pre-trained, and so that you have an opportunity to find a similar model or in the area, or data that resembles, or actually the problem or that resembles the problem that you're trying to solve at hand, and find those models. And so instead of trying to go through all these 1 billion models, you'd filter them out by various criteria, and choose a handful of models, and that will be helpful. Um, that will be helpful to make sure that you are actually testing a few models, and go by comparing their performance, and if it's needed to fine tune. So this is pretty much a different ecosystem now we're looking at, to be able to utilize what is out there.
Okay, yeah, that's great. Yeah. So, what was the name of your product again? Because I think you're also building something similar. You mentioned that you're going to be offering like model libraries for businesses to make it easier for them, right? Did you have a name for the product? I think I missed that.
Unique vision, unique. There are 4 different areas. Everything is called unique because the name of the company is unique. We call it as unique insights for unique text, unique image, unique video. So these are the very specific models, which are pretty much like you can take this. You may have issue not necessarily in, or you may have data just not only in text but image. So the cool thing is that there are several models out there. They are only meant only, let's say, for NLP, for natural language only, or there are some models only that are doing only the computer vision only. There are some only with the videos, but they are kind of in isolation. So what we do is we have the engine that supports your model. Could be a combination. Most of the times, the real data is combination of all of these different possible types of data, meaning that you can't just have numerical data. You may have numerical data, text data, and some images and some videos together that you wanted to process. So our engine actually helps to take all different type of data, unstructured data, and provide you the insights and help you to come up with across the different data types or different data type. It actually provides you the insights across them, meaning that some insights are available in video, some in text. So it will actually cross domain, go into cross data types and provide the insights. That's what is a unique kind of offering that we have. Otherwise, most of these models, as I said, are pretty much specialized into one. What we also utilize onto existing pre-trained models as well, but as well as we have or proprietary work that goes into going on just the particular type of data across and working across multiple data types.
Yeah, no, that's really impressive. I think that's really great because I think another way to get in on this metaphorical gold rush is to sell the pickaxes and shovels, right? Just like in the original gold rush. So that's another idea of building products. Instead of actually solving the problems, make it easier for other people to solve their problems. I also wanted to maybe highlight, you mentioned the models on Hugging Face themselves and the transformer models, GPTJ, things like that. There are other models that, so I guess generally in research, like someone just asked also, we should probably confirm, no one can use Gato right now. It's not open source yet, I think, because DeepMind wants to be careful about releasing it. But you can look at the research and see how they built it, and probably another open source version will come out soon. But the idea also in general is that the bleeding edge versions of these models are typically not production ready, but they're maybe 2 or 3 papers away for being production ready. So maybe in a 6 months to a year, what we're seeing in the research papers today might be available. But what I also wanted to highlight some of the models that are solid, that have been in the last generation of machine learning, in the early generation before we got to transformers. Things like object detection, obviously now is very robust. You can do it in real time. There's mobile models for doing object detection in real time. Segmentation, pose estimation, these are all available commercially for you to solve problems in real time using cameras and computer vision and things like that. Pose estimation in particular, I think is really cool. You can get pose estimation in 3D and 2D and solve problems in physical spaces. And I think Microsoft has a really robust version of this, that's bleeding edge. You might have seen the videos of people dancing and stuff like that. But people have built actually super billion-dollar products on just 2D pose estimation. So I think there's a big area there for opportunity for solving problems using low-hanging fruit and these easy, commercially available models that you don't have to pay for a license. For example, I guess in pose estimation, you could track people in stores, you could track traffic. Oh, you could do you know how there's heat maps for websites? You can make a 3D heat map for stores and give people insight on when they change their signage, how it affects their flow and revenue and how products sell better and things like that. That might be cool. I don't think that exists. That might be a cool product. So, or maybe you could track when people touch things in your store without actually buying it, because I guess retailers only get data when you actually buy something currently. But if you go near things and touch them, maybe they'll give you additional data on what people were actually interested in selling. And maybe if they were interested in selling and the reason they didn't buy was the price, you could just give them a coupon. So that's kind of a cool product idea, I think. And in that same kind of line, do you know anything from the last generation of machine learning models that are solid and usable for products today?
Definitely, there are quite a few models that are pretty good in. It depends because models are very specific to type of problems, and then some are most of these models are available in the libraries. So if you're using the libraries these days like TensorFlow and Keras, a lot of these will also come up with some of these pre-trained models that you could utilize them. Along with the library, there are some pre-trained models that we can also utilize them. But then, obviously, as the time evolves, there are different needs, different challenges to the data. As we just saw in last couple of years, things have changed drastically, and especially with the time series models that were being built. They were not necessarily be continuing to show the same patterns during this period of very unexpected behavior that hasn't been seen in several decades before, or maybe a century before. So that's also depends on what type of problem that you're solving, and will that be able to be answered or solved using the existing there are TensorFlow models and data sets. You can try. You can. There's a PyTorch Hub has also a good number of models that you can see. There's also another site that you can and not very popular, but Papers with Code is another site where people have been presenting research papers with real actual code with it, so that in academia there have been all these decades there have been people researchers have been publishing papers but no code, but then it's hard to get that code and reproduce that result. Now that this site called Papers with Code, code, this site also has tons of papers with actual implementation, and it's really cool to see the data, the paper, and the results and the code, everything there, so you can really run yourself and see if this is something that you can take it and apply to your problem before you're actually trying to build everything from scratch.
Oh yeah, no, that's really exciting. I'm really glad you said. I haven't seen this before. I like the what is it? The YouTube channel 2-Minute Papers, where he goes over papers. This is actually a cool segue into like the next topic I wanted to discuss. So I feel like there's been some big things recently. Like you mentioned time series. I think the other big thing recently is transformers. So maybe just explain to our users what they are basically. So in the machine learning models before this age, you typically did maybe you had neurons that affected their surrounding neurons, to make it very basic. But now we have this thing called transformers that have something called self-attention that allows you to affect every other piece of data in your data set. So it's like a huge statistical model for the probability of everything to every other thing. So that's kind of this new exciting idea that allows you to get insight from just random areas in your data set that maybe humans wouldn't even know, and has no like spatial or temporal correlation, but still gets you like these amazing large language models and things like DALL-E, basically. And time series, I think the exciting thing is about, I'll try to basically explain, but Nisar, you can do better than me. Is it allows you to build in temporal components to models, so you can do things like doing like frames that affect, like I think the coolest thing recently was megapixel deep fakes, but their issue is that they're not temporally sound. So that maybe in like 2 more papers, they'll have enough data to fix that issue. So maybe you could explain it a little bit better. Is that it, right? Can you hear me? Hello? Hello? Nisar? Nisar? Oh, Nisar. Sorry, am I pronouncing your name right? Nisar?
Yes, I can. Yes. Yes, I can.
Okay, great.
Yeah, that's correct.
Yeah, so I was just basically asking, like, I was trying to explain to users what transformers are and time series are, but I guess my next question is, are there any other cool, like, recent developments in research that you're really excited for? Like, yeah, transformers, time series, Google just did something with stuff in, like, Seeing in the Dark, anything like that?
Yeah, there's a lot of interesting things especially with the GANs now helping to produce the content, and that in turn these models are actually producing very close to real type of media or contents, and that also poses some sort of issues. However, so the GAN produced data can also be utilized to augment your existing data if it it kind of resembles the data. And then especially when I have worked with one of the pharmaceutical company, they need a lot of time to run some wet lab experiment, and very expensive. And they would know if the data is right, if it was produced somehow or someone has produced it. But then to change the parameters and to be able to see different data sets produced, it takes very expensive. So I have actually worked with using GAN to actually produce some of these, simulate the experiments and produce the data with varying type of parameters. And it was fascinating to see that it was something that the scientists would be were able to confirm, number one, that the behavior of the processes, and was able to use that to further develop models. Coming back to the question on these problems, so time series problems is like when you have time is a x variable, and then anything else that you want to see what changes with time. Could be pricing, could be demand, could be anything else on the y-axis. So then those, in a very simple terms, is anything that varies with time. Usually with time series, there is a seasonality. For example, if we look into retail industry, say that every uh, every year you'll have similar sales pattern, because, for example, holidays are coming, the weather changing. For example, in summertime there are certain products will sell a lot more, and during a certain type of products will sell more. And those holidays and the summers pretty much or their seasons pretty much repeat themselves uh, uh, in every year. So that a pattern, a time series pattern, and a pattern to look at and compare over several decades, and compare to see that you can see that these patterns are repeating itself. A lot of times when you look at talk to the store managers, for example, they could say, okay, I know what to put on the shelf, and how much to put, because they have actually in their mind they build that model, learn the patterns, and they know exactly what is going to be needed. So they know the demand, they know what is happening, if there are events happening. So these things are, now the knowledge has been gained by the humans, and that knowledge kind of gets passed on to next one, to learn from it, and then and it goes into passing on. But however, it can actually transform the knowledge at once to another human. Humans have the perceptions and presenting it, and other human have also another perception to understand and take it. So there are limitations to how much you can transfer that knowledge over to one individual to the other. So, and there's also limitation now to how many people you can transform it to. However, the machine learning, if this knowledge was captured by the machine learning models, and that can be it can be scaled, and it could be also transformed into it be passed it on to other models, and make this model very much usable. And so this is area that we saw that there is having a challenge in the last couple of years, because of unexpected situations like COVID, and unexpected behavior. So how do you actually combat with these kind of situations? Obviously, there have been publications and ways scientists have, data scientists, statisticians have identified to isolate this problem, and being able to understand their patterns within this area, within this time frame, and build the models that are sensitive to such kind of special circumstances. So that is what the time series models have. been advancing a lot more in these recent years because of this change. And this could be not only Corona or COVID wave, but could be also in areas like there are wars, there are other economical factors in some countries that could affect the time series models.
Okay, yeah, I really appreciate you going in deep. I wish we had more time. I'd like to ask you more technical questions and things like that. But I also wanted to, since we're almost running out of time, I wanted to open up the last bit of this for users if they have any questions on Nisar's experience or any products or problems that you're trying to solve, and you might be curious if there's a machine learning model out there. One of us might have an idea of something. Or any other technical issues or things like that in general. I did, let me see. Yeah, so you were most excited about GANs recently, and then also the ability to transfer learning, but you don't believe that it's possible to transfer everything. So I'm curious, maybe you don't believe in what do you think about the latest research on general AI? Like maybe going back to Gatto as well. Do you think that's a good approach? Do you have any ideas yourself? And how long do you think it'll take?
Great question. Even when it comes to human beings, from one human to another human, transforming all this knowledge, it is challenging. It is because one is limitation in what you can think as possibly useful or relevant may not be translated to something else. When it comes to machine, they are good at certain things of being able to transfer whatever they have learned, which is a great thing. However, looking at new scenarios, for example, what happens in again, I'm going back to the COVID situation. It could be any unexpected in the behavior in the business. How that is going to be tackled by the machine learning models, because machine learning models typically learn from data, the pattern in data. If the patterns in the data is changing, it will keep on using and trying to learn from the data. But there is obviously there is a limitation on how much data does it have, and what is the variability in the data. So there are many different challenges that poses for in learning. So obviously that so it's all again going back to the quantity and quality of the data that will determine how well these languages, these models will learn. For example, there are newer techniques such as YOLO, Phi, or so, Y or yellow. So those are you look only once technique. This is also an interesting area where people have been talking about having need for tremendous amount of data, especially for deep learning models, are notorious about needing to have a lot of data and variability of data. So then there are new models which are able to quickly learn from simple and a smaller data set like yellow Phi, and which will lead only to look once and being able to to combine to predict what else can be other scenarios, which is very cool. That's something you can look into it, and there's a lot of models that have been developed, applications have been developed, use cases have been developed using Yellow. I also use Yellow for for a image classification, for a cell classification, where there is a process called cell apoptosis, where cells, biological cells, human cells, programmed to die over a period of time. Don't die, then they cause the cancer, and that's a natural process. And if they're not dying, or if they're dying too quickly, that causes also a health issue. And in that case, you don't have a lot of this data available in the experiment. So I use these, newer models, newer technique actually, not models, but you're talking more about now the techniques, which helps to learn quickly from a very small data set that can be helped to 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 come with a more realistic model.
Yeah, I think that's really cool. And so I was also excited about recently there's two models recently that kind of piqued my interest just because of my own experience. So it was similar to what I was doing before. To solve that other problem, we also generated images from multiple viewpoints, and we reconstructed the intermediate images using old school computer vision, something called intermediate view reconstruction. We actually measured the 3D disparity and to depth, a reconstruction of intermediate spaces and things like that. So it kind of allowed you to fly around. But this is way more advanced than that because it actually understands the context of the scene and the 3D structure of the scene underneath. So it does actually correctly reflect light and occlude things and things like that. Those are problems that we could have. It was very difficult to solve. I guess it's possible now. But the other cool research paper I noticed recently, there's megapixel deepfakes. So I think that's going to be another big explosion. I guess when object detection and when Google search and stuff like that came out, it changed the world and made it completely different. So I feel like that's going to be another issue with deepfakes. It's not perfect. If you go look up the videos, you can still see that there may be 2 or 3 papers away from being perfect in HD resolution, but they're getting very close where you can just look like anyone else. I think a good application for that would be VR avatars, actually. So I think another thing in the recent news is how Meta is failing terribly to sell the metaverse. And because it looks because it looks very cartoonish and Second Life and stuff like that. But I feel like people aren't really looking at what it'll look like maybe in 6 months or a year from now. Because some of these models, like this deepfake model, could be, you can actually move the viewpoint of the camera. So you can extrapolate an algorithm that generates a 3D version of that just by triangulating or space carving or something like that. Or just train it from the model directly. I've noticed that it's better to just go end to end. The model just, instead of having a human try to inflict some insight, it's better to just give up and say, we don't know what we're doing. And so I guess some of the new products, I guess we could build on these things. I think VR avatars is probably, it could solve Meta's problem. And I guess the issue is that in VR, when you look at other people or even yourself, there's an uncanny valley even in yourself, because if you're moving your hands and things and you're not seeing the motion in VR, you kind of get nauseous after a while and it doesn't make sense. Or if you see the wrong motion, it doesn't make sense. So I think very soon you could look like anyone else. We could be doing this interview looking exactly like ourselves in a virtual world or something like that. And that's only 2 years away probably. I think the biggest roadblock for that right now is honestly not the software. I think it's the hardware, because I think the reason Meta looks so crappy right now is just to run on those headsets. You just have to make it look crappy. You could make it look way better now if you had the technology. So anyways, the other question I did, did anyone else have any questions? Let me look back real quick. I think, oh yeah, Profil mentioned if there's any machine learning models applicable to real estate. And let me see if there's any other questions. We'll get through those real quick. TensorFlow. Cool. Yeah. So do you know any models? I don't think I know any models. I mean, just the general object detection models, specifically for real estate, Nisar, or have you helped anyone in real estate?
I have worked with another company in real estate space, and we looked at the a model that was improve some of the issues that had with Zillow and other real estate engines, and this was more of a custom design model for a client. There are, to be honest, to be able to use a off-the-shelf model, real estate would be quite a undertaking, because not only that you are looking at the data which is available from the publicly available data, but also a lot of things is going into being able to take the what is happening in the economy. So it's economy driven industry is very much volatile in that sense. Affects a lot more with what's going on with the just like what we saw in the COVID situation, how that affected the economy and that affected the real estate industry as well. So looking at only the real estate, data from last 20 years or 30 years, how the prices, you could build very nice mathematical models, statistical models, and they can forecast what could be the normal trend. But then where AI comes into picture is where you are able to really leverage on additional features, additional data set, to really make this more of a realistic prediction. That's what is important. That's how, I mean, I have helped a company to solve the pricing model that has been studied for last 40, 50 years. But then why it is so important again is because the new data is available out there, which is social media data available, and the weather data, which all of that needs to be taken into consideration. Demography data needs to be taken into consideration to make the model very realistic, and that's what is going to be a difference. That's going to make a difference. Otherwise, to be able to use the shelf realistic real estate models, are probably more mathematical oriented and statistical oriented, which could work to a certain extent to be augmented.
Yes, thank you. That's really cool. And then you sold it to them, and this is like a product you sold to them through your startup. Is that correct?
Correct. Yeah.
Oh, that's impressive. Cool. And I guess another follow up is current market price models. Is that, do you know what that means?
Yeah,
It's okay.
The pricing model is actually across industries. Pricing model is very sensitive, and it needs to be revisited, as I mentioned earlier. It could be a retail industry, could be real estate, or could be any other market pricing models. So these are so I probably had to reiterate what I had said. So I think there's needs really to be able to leverage on the tons of unstructured data available to get the insights, and how those insights, those factors affect this model, rather than just looking at the train on the numerical terms or categorical values that you have seen in your internal data. Internal data meaning that the transactional data.
Oh yeah, I understand what you're saying now. So like the models of their pricing, and how do they do it now? They just use like historical pricing, I guess, and then no one actually goes out and, I guess one way you could solve this. What are the unstructured sources of data that you're mentioning? Yes.
That's right. So data typically for any of these pricing models is, for example, if it's a retail store, or if it's a real estate, or any of this, if you can take into consideration your transaction data over the years, that's fine. That will generally provide some sort of trend and forecasting or prediction. However, if take into consideration, if the model takes into consideration other external factors, such as how the competitor prices, and the demography, and the ever-changing weather and economy, all of these factors, that's really actually is affect now. Now, since we are living in an age where a lot of factors are influencing each other, so it becomes really complex, and to be able to get that phenomena into the model is what is needed, rather than just trying to look at the more statistical.
Okay, cool. It seems like Profil is really interested in this. Maybe since you've done it before, your startup has done this before, he could consult you directly on the project if he's interested in.
Yeah,
that'd be cool. Selfishly get in my question, and then we can answer some questions for me. So I was curious about, you mentioned that you had a patent published or granted, and I guess my understanding is in machine learning, like most of the research is published, so it's hard to get a patent on things. So what did you do? Did you spend like years researching like in stealth and then build something, or was it like part of a company that decided to do like private research and stuff like that? And
Right. It is a indigenous, not sponsored by any company, but it's more about, when we look at study the problem in detail, especially in the computer vision, and looked at the state of art in the industry and the challenge and what is really needed for the industry. It's like you could do theoretical research and still get a patent, but then really what our focus is, my focus has been into using that is patentable and also being productized as well, can tag to the product. So that way a product is back some patent, and so this is more into the application perspective where how we can embed and compress the information in in a space where, especially for example, we're talking about small sensors or smaller devices. Nowadays we are looking at wearable sensors. Like sensors could be wear in the shirts, t-shirts, or into the shoes, or everywhere people can wear the sensors, and those sensors have very limited amount of memory and processing power. So the challenge is there to be able to is to be able to embed maximum amount of information that is needed, so that it doesn't have to depend on communicating and requesting for a lot of information from other sources when it is not available. So that's where this research has helped into coming up with a patent and to embed this with a different type of encryption into in a smaller amount of memory, a lot of data, so that you can have this sensors function when if there is a disconnectivity from the internet, right, or from the servers. For example, if the sensors are continuously getting feed from the servers, what happens if there is no connection? For example, if you have this shirt with the or some embedded IoT devices which are going into the areas where there is no connectivity, how they would function in a near scenario. So that's a real problem, and that's where we have solved that problem and turned that into a product.
okay, I see, I understand. So I guess to understand for myself is you saw the space in the market, and as like you wanted to maybe as like a defensive moat to add to your startup's patent library or IP protection. You saw like a future, like the problems that are existing that you could solve today that are not like theoretical. Is that basically it, right? All right, cool. And then so we're almost out of time, so thank you for joining us. I just wanted to answer like this last question. Andrew mentioned that what's happening in CheatLayer recently. So we've been working on this product for the last year to solve the root problem that we set out to solve. If you don't know, CheatLayer solves business automation problems, and we launched last year when we were the first to get approved from OpenAI to use GPT-3 for code generation. And the problem we set out to solve then was to make it easy for users, non-technical people, to generate any complex automation through simple language. The problem with GPT-3 was it didn't translate, and so we had to actually teach users how to use it. Unless you were a software engineer, you didn't know how to use it yet. And so that didn't really solve the root problem, but we did these things like the boot camp to teach users, and we explained that we were training the model off yet. We got access to Codex recently, which is robust enough to solve this problem. So we basically built a framework called Project Atlas that kind of solves the entire solution space using two models. So we built a UI model, which is an object detection model that allows you to detect buttons, links, images, everything, all the UI components across websites, browsers, programs, anything on desktop as well. So basically, this solves a problem that we've been encountering in our office hours constantly with users daily in office hours, and it's kind of our way to iterate our product. We've noticed like all the remaining problems that are left to solve are basically issues with selectors when websites update their selectors, automations break, and things like that, or issues with security in browsers. And all of these can be solved using computer vision and machine learning at the desktop level. So that's kind of the idea behind Project Atlas. We enable users we built a default model that's very robust at detecting like buttons and images and things like that. But we also enable users to train their own custom machine learning models to detect any element that normally fails in other tools because of updating websites or changing selectors and things like that. On top of that, we use the Codex large language model that like we've been talking about to simplify our internal JSON automation language such that it understands what users are saying and translates it directly to our internal JSON automation language. And this framework allows us to do a few cool things. Previously with GPT-3, when people like said things like go to eBay and like scrape all the prices or whatever, it wouldn't work because we have to explain that, you have to be a software engineer to explain how to get it to do these things. Now, it will either tell you that we don't support this yet because we've been able to train into Codex the concept of not being in the data set. And if it does support it, it'll actually understand what you're saying in whatever weird way you say it and map it directly to our JSON automation language with whatever weird parameters you have. So you can say like, go to Google Maps and get the prices. No, go to Google Maps and get like the website, phones, and images, or just get the website and stuff like that. Or go to any website and just get all the links. So it immediately enables automating millions of websites. So there's like this base set of automations we enable for all websites that you can generate like instantly. And the idea is we finally solve that root problem. So using object detection plus Codex as a language layer, we are able to meet users at their level of understanding. The remaining problems we have now is just to keep training it. So as I mentioned, it understands the concept of something that we don't support yet. But it's very easy to add new deep automations and things to this model just by users telling us what's relevant. So we're gonna finally realize that original of like iterating on what users actually wanted, solving like problem through office hours, and building our own custom model where the defensive moat grows daily. So every day we have office hours, users come to us, they show us like relevant automations and things, and our model gets stronger in such a way that it's harder for competitors to compete with us. So expect a big blog post explaining how all that works shortly. I got kind of delayed in the last few weeks, but we're very close. We've been working on it for like a year, so we just don't want to maybe rush the last week or so. But there's also going to be a big 300 code giveaway to help us accelerate training for this. I really wish I had time to ask Nisar maybe some advice. I'll send you a message later. Or maybe this was really fun, Nisar. We obviously ran out of time, and I have like a bunch more questions for you. So you're welcome to come back. Thank you for joining us. And yeah, that's it, guys. This was a great meetup.
Great, thank you very much. I really loved the questions and love to continue to attend the meetings.
Cool. All right, guys. See you guys next week.